Hi, Bio20. Welcome to part 2 of Circulation 8.1, where we talk about the heartbeat and the ECG, electrocardiogram, and blood pressure and some cardiovascular disorders. So when we're looking at the beating heart, I'm going to go right to the picture. We have two nodes that will conduct nerve impulses, and the first one is the SA node, which is also called the pacemaker, because it will start the beating of the heart, and the electrical impulse will actually surround the atria. This one's on the right atria, but also the left atria. So basically it's like if you squashed both your hands like two lemons, one in each hand at the same time. There is a impulse that basically contracts both atria at the same time, which then connects to the second node, the AV node, which is called that. This one's sinoatrial, this one's atrial ventricular, and it's between the atria and the ventricles, so it got that name from that. But when the two atria contract, that will then signal the AV node to start its conduction of electrical impulses down and surrounding both ventricles. And these yellow lines on the heart are called it's sort of signifying the nerve bundle of neurons that are conducting the impulse. And the bundle here is called the bundle of His, that is coming down in the septum, and it branches, and this is showing you like a flat view, but if you can imagine those neurons surrounding all the way around three-dimensionally around both ventricles to cause that the ventricular contraction, because it takes major contraction to stimulate all the muscles of the heart. So the heartbeat consists of the SA node causing all the atria to contract, and then the SA node causing the ventricles to contract. Now, when the contraction happens, it shows up as a rhythm on an electrocardiogram that is also called ECG. They can measure the conduction of electrical conduction through the heart. And what you get on a little ECG paper, maybe you can look up a picture of one. I'm not sure if I put a picture of one here, but you get repeating PQRST waves on a little electrocardiograph paper coming out of the ECG machine, or you see it digitally on the ECG machine. But the P wave is the one created when the atria contract. The QRS wave is the one that's made because at the ventricular contraction, and the T wave is like a recovery sort of indication of a recovery of when there's the heartbeat is over. So it's a small spike as the ventricles, which had a very big contraction, as they sort of relax to fill up again, that you get this T wave. So a normal PQRST wave looks like this, and so those who study the health of the heart would know if what is wrong, or if there's a heart attack or a heart murmur or a problem with one of the heart valves by looking at the ECG. And if you have a racing heart, you would have more of these in a certain area of your paper. And so this is used as a diagnostic when looking at the health of the heart. This picture is showing that when the SA node makes both atria contract, you get the P wave. It shows you when the AV valve causes both of the ventricles to contract, you're going to get this PQRST wave, and then when the blood is filling up in the ventricles and it's being sent out to the lungs and aorta, you're going to get that residual T wave there. Now, interestingly, I always have students like walk through a doorway and then slam the door, and I tell them it's not the blood flowing through your heart that makes a sound, but it's the closing of the valves. So the lub and the dub, because your heart kind of makes a lub dub sound. Those sounds actually come from the AV valves closing, make the lub sound, and the semilunar valves closing make the dub sound. So as they close, because there's pressure of the heart to move past, and right behind it the valves are being shut, that sound, the heart rate, the heartbeat sound, are actually sounds of valves. Little link here on ECG, that'll be great for you to take a look at. Blood pressure is created when the ventricles are forcing blood through your vessels, and as the ventricles are contracting and forcing blood, that would be a very high systolic pressure. When the heart is filling, though, we call that a diastolic pressure. It'll be lower because it's not. It's when the blood is still has the residual pressure of flowing, but it's when the heart is filling, so there's no active contraction at that time. So what you guys may have seen before is the classic 120/80 blood pressure, and that your blood pressure is compared to. And so the systolic pressure is the one on the top that has the higher pressure, and the diastolic pressure is the one on the bottom. If you just think of like a plant dying, it's like the lower number. Diastolic, it's not the high pressure one. So normally, as you exercise and you can have your systolic pressure go up. Blood pressure is looked at because too high of pressure in your vessels could cause especially damage in your tiny capillaries, like in the eyes and in the kidneys. So high blood pressure is not a good thing, but they sometimes can diagnose other problems in organs and diseases by looking at blood pressure. Blood pressure being really low also could mean that there's a burst vessel, or because of an injury or a aneurysm or something. So lots of reasons blood pressure is studied. A sphygmomanometer, big word, but that is the machine that it either manually you pump a little cuff or you just hook it up and plug it in. The sphygmomanometer is used to measure blood pressure, and typically it's measured in millimeters of mercury, and that was used in the old mercury type sphygmos, and so they still use that as a unit today. But as you have higher pressure in your vessels because you have cholesterol and the vessels are blocked, pressure could go up because of that reason. Pressure could go up because of exercise, could go up because of smoking, stress, could be even dietary, lots of reasons that blood pressure can go up. But some people with concerns on that sometimes are being monitored or have a sphygmo at home to monitor their blood pressure. They mentioned some concerns here that I already talked about that could lead to issues with your kidney, for example, or too much pressure in your brain. You don't want the brain aneurysm. So there's some things to watch out there. And this cardiac output is how much blood is coming out of your heart in milliliters per minute. And to figure that out, we look at how much blood comes out in milliliters with every beat. And we also look at your heart rate, how many times so milliliters per minute, and how many times it beats, your heart rate. So when you multiply those two things, you'll get your cardiac output of milliliters per minute. The stroke volume, it will depend on how healthy that heart is. So it says here that if you have a stroke volume, average person, about 70 milliliters comes out of your heart with every beat. And most people at rest have around a 70 beats per minute heart rate. That means that you're moving almost 5,000 milliliters or 5 liters, close to 5 liters of blood every minute from your heart. That is a lot. That is actually about how much blood your heart body actually has. So when you think about that, it means that all of the blood in your body moves through your heart every minute. And that's kind of fascinating trivia. All right, so stronger heart will mean that you will be able to move more blood per beat, so you won't have as many heart beats per minute. So some athletes are found to have like maybe like instead of 70 beats per minute, they could have even half of that. And there could be a resting heart rate that's very low because their heart is so strong from all their training. And so that's a possibility. You can read more here about how it's good to have cardiovascular and strength training together to have a healthy heart. Okay, a couple good videos for you to check out. For pathway, we talked about how the heart has the pulmonary circulation where it sends blood to the lungs and back, but it also has systemic circulation where it sends it to the body and back. So on top of that, the blood is actually feeding the heart muscle itself. And so on top of that, we have to realize that there is this cardiac circulation or coronary circulation that's sending it right to the to this heart as well. You guys have this photo in your notes that you can fill in to review the pathway in a linear way here and follow all the structures that blood would flow to if you're a blood cell making your way through the heart and around the body. It would take that pathway. So check that out. So capillaries are going to be, well, arteries and capillaries branching off of the heart itself. So coronary circulation, besides to the lungs and back and to the body and back, we've got blood going to the heart and feeding the heart and delivering oxygen and collecting carbon dioxide. So this is just showing you some of the coronary arteries and coronary veins. And the reason this is looked at a lot is because if someone has a heart attack, it is one of these coronary arteries typically that is blocked with cholesterol perhaps, and then blood can't get past that point and can't feed that section of the heart, at which point that section of the heart dies. It's painful, and that is what a heart attack is. So someone could have a blockage that blocks such a significant amount of the heart where one heart attack could be deadly, or it could be a little part of the heart, in which case they can be fine. But typically they when this happens, they check out by putting dye and flowing it through here, check out whether there is any other blockages like you see in this image here. Wherever there's a blockage, then you see that there's no dye going past that point, so they would check that out. And if they find any other blockages, they could then go in and put in a stent. So that would be right over. No. I thought I had a picture of the stent, but it's a video actually of how I think this is a picture of someone's heart that actually has a stent put in because of a blockage. So they found out this person had a heart attack, and they found out that they had other areas 70% blocked and 90% blocked. And so they put in a couple of stents, which is a wire that pops open and opens that area up so that there is no blockage there. But of course, that person is encouraged to have a healthy diet from that point and exercise, and maybe sometimes includes weight loss to make sure that it doesn't have another blockage. We also know that this blockage or fatty deposits in the blood vessels is called atherosclerosis and could give you angina, which is chest pain. Here's some tips for a healthy heart. Not to smoke, have a good diet. A heart murmur, maybe you've heard of that. This is where the valve is not entirely closing off when the ventricles are pumping and there's some backflow through those valves. So if there's backflow through the valves, you can hear it as a little sound, and that's a heart murmur. And sometimes it's not that serious of a thing, but if the heart murmur is serious, it could be because that valve isn't functioning. So sometimes someone does need an actual valve replacement. Okay, so clots obviously can impair flow of blood through vessels and through the heart. An angioplasty is what's in this image here, where they basically go through a closed artery, and it used to be something that was done to just inflate this little balloon and basically squash that blockage, the plaque blockage in there. But now they do this angioplasty and usually insert that metal stent so it keeps it open, because they found that even though they squash it and open that vessel, sometimes that just closes back up again. So now that metal stent, as I was showing you in this image, is what they put in. Bypass, coronary bypass, would be if there is a damaged and blocked vessel. What they could do is take a grafted vessel, a vein from some other place in the body that doesn't really, vessels can regrow, especially small vessels. So sometimes these are taken from legs, and they can say, well, if we've got a blockage here and the blood can't go past that point, they would take a vessel and graft it and be able to, from the aorta, send the blood to this area of the heart that isn't getting blood because of that blockage. So in this case, this person got 1, 2, 3 grafted vessels that are feeding the lower parts of the heart. So that's what that is. All right, that is a wrap for 8.1. Lots of super awesome videos for you to check out. One's on energy drinks, one's on people getting heart transplants and getting some cellular memory from the person that donated that heart. Kind of interesting stuff. And we will, of course, be assigning some review from your notes. So thanks again for listening to part 2 of 8.1, and I will say bye for now.